All right, welcome to Unit 3. We are starting today with our exponent rules. So we're going to go through those notes together. I have 3 examples at the end. So the first rule is the 0 power rule. So anything that's raised to the power of 0 is 1. For example, if I have 5,207 raised to the power of 0, it's 1, no matter what. So any number x raised to the power of 0 is equal to 1. Our next power is the negative exponent power. A negative exponent tells us how many times to divide by that base. That means we're doing the reciprocal. So we're going to end up seeing some fractions, y'all. So for example, if I have 5 to the power of negative 1, well, this is 5 over 1. So 5 is going to go down to the denominator. On the flip side, if I have something in the denominator, that's going to go to the other part of the fraction and become 2 to the power of positive 2. Now, this will only apply to the thing itself that has a negative exponent. And you'll see what I mean by that later on. So here's my general form. Anything to the power of a negative number goes to the opposite part of the fraction. And if at any point in time you need to pause the video to jot down the examples, you're more than welcome to do so. Next one is our product rule. So I have 2 like bases. That means the big number on the bottom. They're being multiplied together. I'm going to add the exponents. So for example, if I have 3 squared times 3 to the 4th, that becomes 3 to the 6th. So, because I have 2 3's here and 4 3's here, so altogether I have 6 3's that are multiplied together. And there's my general form there. Quotient rule, so if I have division happening with like bases, so if I have 3 to the power of 2 divided by 3 to the power of 5, that'll be 2 minus 5, which is negative 3, which is 1 over 3 cubed. Another way I can think of this, I have 3 to the 5th on the bottom, 3 squared on the top. So I have 5 3's down here, 2 3's up here. I know if I get rid of 3's that match on the top and bottom, they're going to create 1. So I know I'm going to end up having 3 left over because 5 minus 2 is 3. And they're going to go in the denominator because that's where there's more 3's to start. So that's another way you could think of it. So if you're going to do the subtraction rule just as is, it's always top minus bottom. Power rule, if I have a base to an exponent that gets raised to another exponent, I'm going to multiply the exponent. So I have 5 squared cubed. So I have 5 squared times 5 squared times 5 squared, which is really 5 to the power of 2 times 3, which is 5 to the power of 6. And there's my general form there. If I have the product of a the power of a product or a quotient, I'm going to distribute the power. So for example, if I had 5 times 2 times 3 squared, that's like 5 squared times 2 squared times 3 squared. You could also see it this way. If it's a times b times c squared, all of them get a squared. Or if it's a fraction, both numerator and denominator are going to get that exponent. So we're going to go ahead and start doing our examples together. All right, so I have 3 pieces in my first parentheses. Technically, 3 has an imaginary exponent of 1. So I'm going to do 2 times 1, 2 times 3, and 2 times 2. And those will create my new exponents. So the bases are going to stay the same. The thing that's going to change is my exponents. So 2 times 1 gives me a new exponent of 2. 2 times 3 gives me a new exponent of 6. And 2 times 2 gives me a new exponent of 4. Now I'm going to do the same thing over here. But I do have to be careful because -1, anytime it's a negative number that's getting raised to a power, I have to make sure I remember the negative and the 1 are glued together, and I have to deal with that as a thing itself. So technically all of these have exponents of 1. So I'm going to distribute this 3 to each of my exponents. So I have -1 cubed, a cubed, and b cubed. So before I do anything else, I'm going to actually simplify these two coefficients. So 3 squared is 9. -1 cubed. So that's -1 times -1 times -1. Well, -1 times -1 gives me +1 times -1 gives me -1. So this will be -1 a cubed b cubed. Now I can start putting things together. Coefficients get multiplied. So this is like 9 times -1. My a's, since they're being multiplied together, I'm going to add exponents. So I'll have a to the power of 6 plus 3. Same thing with b's, b to the power of 4 plus 3. So 9 times -1 gives me -9. 6 plus 3 gives me 9. 4 plus 3 gives me 7. So that would be my simplified exponents from this original question. All right, now I've got a whole lot of stuff in fraction form. So the first thing I notice is that right here, I have x to the power of 0, which means that is a 1. So that's gone. Then I notice this y squared has a negative exponent. I'm not allowed to have negative exponents. So I'm going to move that to the bottom, and I'm going to start to rewrite this fraction. So I'm going to put all the stuff that I have moved in the front. So y to the -2 is going to go to the denominator. So I'm going to put y squared in the bottom. This x is the only thing that this -1 exponent applies to. So that's going to go down to the bottom. And it'll be positive. I'm going to put the 1 there just so we remember. And this -2 only applies to this x. So I'm going to put that up to the top. All right. So now I've got times 4x times, remember now I only have 3 because this moved down to the denominator. And now I'll only have x to the 5th because this moved to the denominator. So now in addition to the stuff I've moved to the bottom, I've got -3, I've got y squared, and I've got +3. So the next thing I'm going to look for is if there's anything that's identical in the numerator and the denominator that I know is going to also cancel out to create 1. Well, I see a 3 in the numerator and a 3 in the denominator. They're both positive, so I know that those are going to cancel out to create 1. And I also see an x to the first power, which will also cancel out to create 1. So now I can rewrite that. So I have 4 times x squared times x to the 5th in the numerator. and negative 3 times y squared in the denominator. Now 4 does not equally divide by 3, so I'm going to leave that as it is. X squared times x to the 5th, I can combine these two exponents using addition. So that will be x to the 7th. And y squared, I can combine those using addition because they're on the same level of my fraction. So that would be y to the 4th. And that is the end of that one. All right, last example, example number 3. Now you could choose to go about this a variety of different ways. You could move this whole set of parentheses down to the bottom since it has this extra negative exponent. You could distribute that negative exponent first and then move stuff around. It's totally up to you. I'm going to distribute the negative exponent first and then deal with what I have to move. So this is going to turn into x to the power of negative 2, y to the power of negative 3, z to the power of positive 1. And I'm just going to leave it at z. Then I'll have 3 times x cubed times y to the negative 5th times z to the negative 2nd. So now anything with a negative exponent has to go to the opposite side of the fraction. So both of these pieces in the numerator have to move to the denominator because they both have negative exponents. And then y and z here need to move to the numerator because they both have negative exponents. So that's going to become z times y to the positive 5 now, z to the positive 2, because both of these are coming up. And then 3x cubed was already down there. Now I'll have x to the positive 2, y to the positive 3. So before I deal with the y's, I'm going to combine. We know that's an imaginary one. I'm going to combine what I have already. So that would be z cubed. These I'm going to combine with addition. There's nothing to simplify with the coefficient of 3, so that's going to stay where it was. That'll be x to the 5th. Now I have to look at my y's here and in the denominator. I have more y's in the numerator, so I know that my extra y's are going to land in the numerator. And 5 minus 3 gives me 2. So I know that those 2 y's are going to land in the numerator. Now, if this was a multiple choice question, your variables will be in alphabetical order. So your final answer would be y squared z cubed over 3x to the 5th. That's if it was a multiple choice question. But in our classroom, it's okay if they're not in alphabetical order. If you gave me this as an answer, that's still, this is still totally fine.